Okay, so ladies and gentlemen, we've been focusing lately on equations that have fractions in them, but not so much on equations that have decimals in them. So today we're going to focus on how to deal with equations with decimals, and it's very unpleasant. So just as when we had to deal with equations with fractions, the first thing we did is we got rid of the fraction. What we're going to do with this is we're going to eliminate the decimal. So that's going to be our goal. And the way we're going to do that is by multiplying. And then solving becomes easier to do in your head. And so what you have to do is take a look at your equation and consider what number you should multiply by so that you have no decimals anymore. So when you look at the different coefficients here, what place is the 0 in? Tenths. And then the 5 is in hundredths. Tenths. And then we have tenths, hundredths, and then tenths. So what that means is because the highest is the hundredths place, we're going to have to multiply both sides by 100 to account for that. So I'm going to multiply this side by 100. So if the highest place is the hundredths place, I'm going to multiply by 100. If the highest place is the 1,000th place, I would multiply by the 1,000. If the highest place is the 10th, then I multiply by 10. And what that does is it clears my decimal. So multiplying by 100 means I move my decimal spot 2 places to the right. So this is actually something we can do in our heads. So this goes 2 spots to the right. The reason why it's 2 spots is because 100 has 2 zeros. So 100 times 0.05 is 5c. Because multiplying by 100 is moving the decimal 2 spots to the right. Multiplying 100 by 3, I move the decimal 2 spots to the right, and I fill in a 0 because it has that empty position. So that becomes plus 30. All right, because the goal is doing this without a calculator. Multiplying by 100 has 2 zeros, so you're moving the decimal 2 spots to the right. So over here, 0.21 times 100 is just 21, because the decimal goes 2 spots to the right. And then 0.5 times 100, 0.5, if I want to move the decimal 2 spots to the right, I count 1, 2, and I fill in a 0. So that's 21 plus 50. C. Okay, as I got right up there. Questions so far? Right. So since 100 has 2 zeros, you move it 2 spots to the right. If we're doing 1,000, you do 3 spots to the right because 1,000 has 3 zeros. Okay, so what side would you guys like to move your C on? The right or the left? How about you, Isaac? What side do you prefer? You want to move them to the right. Okay, so I'm going to subtract 5c on both sides. If I do that, the 5c's cancel over here, and on this side, I get 30 equals 21 plus 45c. Oh my goodness, sorry. Not going to cooperate today. Now, I'm going to subtract the 21 on both sides so I get the real numbers over to the left side. I get 9 equals 45C. And I just moved the 45 over so there wouldn't be a super big space there. And then I'll divide both sides by 45. Now, can I reduce 9 45ths? Brendan? 1/5. Good, because 9 goes into itself, and it goes into 45. Now, there's no way I could have done that in my head, well, without probably making an error, without scaling this by multiplying it by 100. So multiplying it by 100, I could do the whole thing in my head, and then I get all that. Questions?
If so, you can't just you have to show the part when you multiply times 100. Like you can't just move the decimal.
Oh, that's fine. Yeah,
You just move it.
you can do it. You just have to, moving all the decimals over 2 spots to the right is the same as multiplying by 100.
Yeah.
So as long as you're doing that correctly, you don't have to show that. Especially if you realize, you need to realize that that's the same thing. But if you realize that, then I'm good with it. All right, other questions? So when we look at the decimals, we have a 10th place, but we also have a 100th place in this first decimal. The 2 is in the 100th place. So I'm going to multiply this side by 100 as this side. And again, 100 multiplier means you're moving the decimal 2 spots to the right. So 0.12 becomes 12. 0.4 becomes, DJ? 40. 40. Good, because if you look at 0.4, you move it 1, 2 spots to the right, and we fill in the 0. Now, you might think, yes?
Oh, wait, no, I was going to answer you too.
Okay. Now, a lot of people on the right might think, oh, you don't have to move any, there's no decimals over there, so I don't need to multiply. Well, to keep the equation balanced, you do have to do the same thing on the right as you do on the left. So Denise, what do you get when you multiply on the right? Yep, 200 minus what?
Oh, that 100.
Good.
Oh, that's wrong. My brain was thinking.
I'm going to tell you guys what I tell my seniors. The most important thing about yourself is being nice. So in other words, don't be a jerk. So I'm going to add the 100 to both sides.
Yeah. Wait, why did you do that? Oh, it's also.
Yeah. If we don't get to the end of the lesson, you will be confused on the homework. So I'm going to suggest that you quiet down. So we get 112x minus 40 equals 200. Now we're going to consolidate our regular numbers to the right side by adding, Brandon, go ahead.
Positive 40.
Good.
When you get 240 on that side.
Divide by 112. And I don't know that is going to be a decimal. They don't go in evenly. But we are not going to write it as a decimal, are we?
No.
Is it reducible?
Yes.
Yeah. So first thing I'm going to do, I know those numbers are even. So I can just start dividing by 2. So this is 120 over 56, dividing by 2. This is 60 over 28, dividing by 2. 30 over 14, dividing by 2. and then 15 over 7. So that's not the most effective or efficient way, I should say, but I can divide by 2 in my head. I probably could have done 4 as well, but this got me there, right? I know 15 and 7 don't have any common factors, so I know I'm done. And these continue to be even, and I know even numbers have a common factor of 2. Yes?
If we put the decimal form and the fraction form, does it really matter, or do you want it like just decimal?
Just fraction form?
Yeah, just fraction.
No, you're not going to have points off for having. The thing that annoys me if you have 2 answers on the paper and they're not the same, and they're both circled, it's people that put multiple answers down, one that's right, one that's wrong, and I'm supposed to figure out. Yeah.
Okay, so like,
Yeah, don't do that.
so like the decimal version of that would be 2.14. If I put that down, and I put 15 over 7 or 2.140, would it be about 20?
No, I don't. Okay, so there are 2 special cases when you solve. The 2 special cases are this: inconsistent equations and consistent equations. So not all equations are solvable. Every equation we've gotten so far has been solvable, but not all are solvable. And if they are not solvable, they're called inconsistent equations. And that means no value of x will make the equation true. And let me explain to you what that looks like. For example, x equals x plus 1. That is an example of an inconsistent equation. The reason that is inconsistent is because if I solve that, I would subtract x from both sides. And I would get 0 equals 1. Does 0 equal 1?
No.
No. So this is false. If your variables cancel, you are going to get either an inconsistent or a consistent equation. If it's false, that means you have an inconsistent equation, and that means there is no solution. And here's my example of that right here. So these special cases happen when the variables cancel. Another example I can give you would be an example of a consistent equation. A consistent equation would be something like this. 2x plus 3 equals 2x plus 6. If I go ahead and solve that, what's going to happen is I'm going to distribute. And when I distribute, the following will happen. I will get 2x plus 6 equals and then when I subtract 2x from both sides, I'll get 6 equals 6. Is this true or false?
True.
True. So if you get an equation that is true, that means it is true for all values of x. So that means it's always true. So an inconsistent equation is never true. You can plug in any number for x and it will never work. A consistent equation is true regardless of what number you plug in for x. Any number works. And so this is what happens when the variables cancel. You have one or two things happening. Everything else is called a conditional equation. So everything else that we solved was conditional, meaning it is going to work only with one answer. So a unique solution. So that would be like x plus 7 equals 10, x equals 3. That is what we have been solving, our conditional equations. All right, so 3 different types of equations. Any questions? All right. So I'm going to throw up the homework. Sounds bad. I'm going to advance the slide and show you the homework.
Oh, yeah, I'm getting, we did.
Okay. Oh, you see that double. Stop.